before anybody gets in here. Let's see if we can break the internet. Oh. Cool. Technology. Let's go ahead and get started. If you ask the questions you want to ask, you can get out of here, no problem. What kind of questions do you have?
Can you go over number 8 for the word problem?
Absolutely. Let's start there. I'm going to share my screen. There we go. All right, so let's just go ahead. Yeah, these are, so I circled the ones that I worked out either on the video or the notes. So you should have ways to find the answer there. You said number 8, I think. Okay.
Yeah.
So one thing I've been doing, I did this with the other class, and it's probably a good idea, is just to copy the problem. And Notability is wonderful. You can shrink it down as small as you want it, but it's nice to do the work while you're looking at the problem. So I kind of just copied them and brought them down here. So I'm in box number 8. I can see the question. I can see everything. So, all right, what do we start with?
Finding our variables.
That's right. We got to define what the variables are. So again, usually when I attack these, I don't even read the question. I just look at what they're trying to get me to find first, because if we just keep it simple like that, that's how we know what to define our variables as. So all it's asking us is how many computer monitors weigh 40 pounds. All right, so what would one of our variables be? And Lainey, I don't know if you know, but you're muted. Just in case, it's fine if you want to be muted.
Oh yeah, I was, because
okay.
My brother, he was.
Okay. All right. So what would one variable be for sure?
40.
Well, 40 is not a variable. Remember, you're writing down what we're trying to find.
Oh, the weight.
Right. Or no, actually not the weight. We know what they weigh, and we know what the total weight is. Yeah. How many? How many weigh 40 pounds? So we're looking for the number of monitors that weigh 40 pounds. So let's phrase that as brief as I can here. Number of 40-pound monitors. Okay. So they only ask us to find one thing, but what do you think, just from the way we defined our first variable, what do you think the other unknown is here? I guess I said I never read the problem first. You should probably read the problem first so you know what it's about. A shipment of computer monitors, some weighing 25 pounds and the others weighing 40 pounds each, has a total weight of 680 pounds. If there are 20 monitors altogether, how many weigh 40 pounds? So what's our other variable?
How many weighing 25 pounds or 20 pounds? 25 pounds. 25
pounds. You're right. Yeah. The y will be the number of 25-pound monitors. Okay. In a system, they always represent like the same type of thing. So we're just looking for how many. We know the weights. What we don't know is how many of each there are. So that's what we're looking for. Okay. So now it's time to write our equations, and this is always the toughest part, and rightly so. But you gotta basically understand that everything is in a story problem for a reason. So every sentence gives us some information about what we're trying to find, and what we're trying to find is the number of 40-pound monitors and number of 25-pound monitors. So anything we know about those monitors can help us. All right. So the first thing we see here, some weigh 25 pounds, some weigh 40 pounds, and here's the total, 680 pounds. So anytime we see a total, we're going to be thinking, okay, so let's write an equation about the weight. All right, so we don't know how many 40-pound monitors there are. We know there's X amount, but we know they weigh 40 pounds each. So if we take 40 times X, that'll give me how many pounds in total all the 40-pound monitors weigh. And then to that, we have to add 25 times Y. That'll give us the total weight for the 25-pound monitors. And if we add up the two total weights for each type, that should be our overall total, which is 680. All right, so there's one equation. And the other thing we know about the monitors is that there are 20 of them. And that doesn't seem like enough information for us to write an equation, but it really is. Since X is the number of monitors and Y is the number of monitors, if we add those together, we should get the total number of monitors. So the second equation is going to be how many. It's going to be the number of 40-pound monitors plus the number of 25-pound monitors equals the total number of monitors. So there's only two types, so we just add them together, and that should equal 20. All right, so it could be 10 and 10, it could be 15 and 5, it could be 20 and 0, but there's really a limited number of options for what our answers can be. All right, so now, hopefully this feels like the easy part to you. Now that we've got the system written down, all we got to do is solve it. So Katie and Lainey, what do you think would be the easiest method to use? Elimination or substitution? I'm curious to get your opinion.
Substitution.
Lainey says substitution. Katie, what do you say?
Substitution.
Substitution. Okay. I think that's what students gravitate toward because they understand the algebra a little bit better. But elimination wouldn't be bad either here. I'm just going to show, we will solve it by substitution, but I just want to show you what you can do with elimination. All right, so remember, all we need to do, get my laser pointer out here, all we need to do is get opposite coefficients on one of these pairs of variables. So I could multiply this whole equation by -40, and that would give me a -40x, and then that would cancel out, that would eliminate the +40x when you add them together. Or if I wanted to eliminate the y's, I could also multiply the entire equation by -25. Okay, so elimination is not bad here. It's really a toss-up, like whatever you feel more comfortable with is what you should do. So let's use substitution. You can see we don't have a variable by itself, but we do have, they're close. In this second equation, we have a 1x and a 1y. So it really doesn't matter which one we solve for. I like getting that x by itself. I don't know why, that's just what we usually do. But so let's take x plus y equals 20, and we gotta get that x by itself, so we're gonna subtract y from both sides. We get x equals 20 minus y. Okay, this will be good because on the other video, I think I solved the same one, but I used elimination. So, yeah. All right. So now we've got this expression. So we're going to take this expression, 20 minus y, since it's the same thing as x, and we're going to put it into the other equation for x. So I'm going to write, let's do this in red. 40 times 20 minus y in parentheses, and then the rest of the equation just goes on as normal. Okay, so to solve this, we distribute. That would be what, 800. 40 times 20 is 800 minus 40y plus 25y equals 680. We got some like terms here to combine, so I'll bring down my 800. -40 plus 25 is -15, so I'm just going to write in minus 15y equals 680. All right, now we got a two-step equation. So now we just roll from here. I'm going to subtract 800 to get a 0 there. -15y equals -120. And then our last step is to divide both sides by -15 to get that y by itself. And that gives us, now, always use the calculator. Even if you think you know what the answer is, it's a good idea. Right? If we do use a calculator here, we're going to get a +8, especially for your sums. That's normally where you're like, especially with this one. When I was a student, I'd be so pumped about like thinking about what 120 divided by 15 is, and I'd get 8, and I'd be like, yes, and then I get the sign wrong every time. So it's good to just put the signs in there in the calculator just to make sure you're getting them right. All right, but what would you think if you got a -8 for y? What's the first thing you would think in this problem? Remember, think about what y represents.
It wouldn't make sense because somebody wouldn't weigh negative. Or
That's
no,
right.
it wouldn't. Yeah.
Oh man, I'm on 10% already. Okay, I'm gonna have to charge this. But yes, you would think it doesn't make sense. How could the shipment have -8 25-pound monitors? Like it can't. That just can't happen. Okay, so we got half of our answer. Now the rest of this is mental math. If there's 20 monitors altogether and 8 of them are 25-pound monitors, then how many 40-pound monitors do we have?
12.
You got it. 12 plus 8 is the only way to get 20. So obviously what we would do is take that, plug it in here, and we would say x equals 20 minus y, which is now 8. So we get x equals 12. But yeah, you really don't even have to show that work because that's pretty elementary. Once you get one of the answers, especially in a case like this, you can just pretty much figure out what the other one is. So, all right, so we're looking for the answer, and this tripped me up the first time when I was talking about the other class. The answer we're looking for is not 12 and 8, it's just 12, because they just want to know how many 40-pound monitors there are. So we go up here, we look for an answer of 12. Okay, there it is. So we cross out, remember, this is what the directions are. And I always like to write where I got that answer, just in case something doesn't seem right, I can go back and check my work. Like if the message is not working out right, I can, check and see maybe if this was different, like maybe it would make sense, and you can figure out where you went wrong. All right. So that's what I'm looking for on all these problems. As you can tell, it really helps to define your variables first. So you can always look back up there and be like, wait, what did x represent again? Like, what am I? It helps you clarify your thoughts, if nothing else. All right, and it also helps you figure out how to write the equations because you don't know how to put these things together until you have something to represent the values that you don't know. All right, so you can plug those x's and y's. All right, what else?
I'm good. I just needed to have an explanation from a teacher. It's hard to learn from the video, but now that I know how to do it.
Awesome. Well, I'm glad I could help. I know, when you were sending them to me, those, especially the ones where it just talks about the numbers, these can be really tricky as far as setting them up the right way, especially with when it says right here, 9 less than twice the larger number. A lot of students want to do, since they see less than, they want to do 9 minus 2x, but that should actually be 2x minus 9 because you're taking twice the larger number and then subtracting 9 from that. So you're taking 9 less than that. So you just got to watch those real carefully. I think that's the type of mistake you made when you sent it to me earlier. So yeah.
Yeah.
They can be tricky and it can be hard to find your mistakes.
All right. Well, thank you.
Yeah,
Yeah,
no problem.
thank you.
No problem. See you girls later.
Bye-bye.